Hello everyone, again, welcome. Today I will be going over a multi-sensor mosaicing with the Geomatica platform. Welcome everyone. Just a brief overview. For this webinar, we're gonna explore what is new for the new Mosaic 2018 tool. And then I will go through detail about the multi-sensor mosaic processing workflow, following the number of steps such as ingesting, image normalization, preparing the mosaic and generating it, as well as some post-mosaic editing, showcase a live demonstration, and then wrap it up and have some time for questions and answers. So my name is Jason Flatt. I am a technical solutions specialist here at PCI Geomatics. And just a few webinar logistics. All lines will be muted during the presentation, but if you have any questions, please feel free to write them in the questions panel. And if there's any other issues, raise your hand if you have a problem as well, or if you want to speak during the QA. And the session will be recorded, but please stay and listen in and stick around. So I have a quick poll I would like to start. I'd like to know, what is your primary objective when mosaicing imagery? And going to launch, we have two questions or two options. Either A, your goal is to create aesthetically rich mosaics for mapping or for visual interpretation and applications. Or B, creating scientifically accurate mosaics for more of a quantitative analysis approach. And you can either use that, produce them through compositing techniques. Wonderful, okay. I'll let this go on for a few more seconds. We're seeing a higher degree of people wanting to produce scientifically accurate mosaics for the quantitative approach. That's great. So I'm going to be closing this in 5, 4, 3, 2, 1. Thank you all for attending, or for setting in the polls. We have around 40% producing aesthetically pleasing, while around 60% for scientifically accurate. Wonderful. So to continue, just a brief overview of our company. For those of you who are not familiar with PCI Geomatics, we are a geospatial software producing commercial and educational desktop packages, developer tools, and enterprise solutions for image processing and analysis. We have a wide variety of offerings, and today we'll be looking at just one aspect of what's new in our desktop suite for Geomatica 2018. Now, just a quick word on what is this image that we are all seeing. Well, it represents the complete offerings that we have. And we like to refer to our software as a platform, a Geomatica platform, if you will. And it is made up of individual software components that can be put together in different types of interfaces. So, of course, depending upon whether you are working with a small amount of data or larger amounts of data, we do have a solution for your type of project. Now, on the left, the Geomatica is a GUI. It's a graphical user interface that allows the users to view imagery and perform detailed analysis, and also capable of some form of automation with our Python API. Now, when we go across the image to the right, we get to higher end productions, which have high volume with our high volume system known as GXL. And it leverages all the technology that's been developed in the Geomatica, but yet allows you to parallelize the process on multiple computer nodes, enabling the users to scale up their projects. So this idea is an important concept that we follow, and we can work with few images in the Geomatica, 200s with some scripting, or even the thousands as you move toward the GXL system. So just a brief introduction on the Mosaic tool for 2018, our newest version. So what is new? For those of you who have used it before, or for those who've never touched it, well, our 2018 release offers a new independent mosaic tool that provides users a far more enjoyable and flexible experience when producing mosaics. The new tool will streamline the entire process from beginning to end, starting with a graphical wizard that assists the user in the preparation of a mosaic project. Once the user has prepared their project, they then will be redirected to the Mosaic tool for the hands-on editing of their data. And the new Mosaic tool also provides many new features that can help with producing high-quality mosaics. So the independence, as I made mention of, it's a separate graphic interface compared to the previous. Offers intuitive and flexible tiling capabilities that were previously not present in the Geomatica. It also has the creation of mosaic.mos project files, which users can directly open from the File Explorer. And it's even possible for them to add images directly into the tool. And the whole goal is to generate a WYSIWYG project for easy QA. Now for the new features, I just quickly made mention of the tiling, but we have cross-sensor support, on-the-fly resampling and reprojection, so images of different resolutions, bit depth, and projection can all be leveraged. We provide multi-user capabilities to Geomatica users without them having to write their own Python code. We have the tiling capabilities that weren't present before, and we have a number of different updates. We have a performance improvement that has been made to the dodging points. That includes both the increase in rendering and editing speed. A performance improvement has been made for reading large mosaic projects, a better handling of larger projects. We've also exposed an auto-scale function that allows a user to normalize their data actually before we perform the color balancing. And then, of course, we've just improved the overall help documentation to assist the users in the Mosaic tool. So before I begin going more in depth about the Mosaic multi-sensor process, I just want to familiarize everyone with the Mosaic generation and editing techniques. So color balancing for mosaicing in traditional sense, users set a single set of coefficients that define the brightness and the contrast of each color band in order for them to achieve good color balancing. The problem, though, is that some images will balance well, but others may not. So their neighbors will have some inconsistencies, and then it will require some time-consuming edits to fix, and in the end result in more of a checkerboard effect. Now, our PCI method is a little bit different in that we utilize something called bundle block photo adjustment. The user actually will set coefficients for each cut line to try and balance just the edge area by way of dodging points. And so it's a two-step process. The user first performs more of global color balancing on each of the images and all the images, and then improves it along the seam lines. So here again, in this example, we have those 6 points, editing the color balance for each image, and then the seam line editing, which can help improve the color balancing and make a seamless result. And I'll go into detail about these steps as we continue. So the multi-sensor mosaic. So before we go into the workflow, I just want to explain a little bit of benefits, like why does it matter? So the benefits of the multi-sensor mosaic is it improves our temporal resolution over our area of interest. So we increase the coverage. As we can leverage multiple different sensors, we have an increase in, of course, data availability. And then because we have different sensors, we've actually reduced the chances of having cloud coverage over our area of interest. Now here is the workflow. It's just an easy to use. It can be interactive or automated for producing the mosaics. It's 5 steps, could be even 4 if you don't have multispectral and panchromatic imagery together. And it's an ingest, a sensor normalization, pan sharpening of the data, and then generating the mosaic, and then performing some post-mosaic edits. Now, the first step is ingest and actually developing a spectral classification. So we can ingest all the raw satellite images into our PIX format and can generate spectral exclusion mask over the clouds and the water bodies. We can either do this through our atmosphere correction cloud masking capabilities. And the pixels that will be covered by these masks will then be excluded in the color balancing cut line generation. For multi-sensor normalization, well, we need to adjust the channels to be the same order, and as imagery can have different units of measurement, bit depths, and scaling, we're going to need to normalize everything for color balancing. And of course, channel mapping is important, and it must be the same for each image. So here's just a quick example of the raw imagery for Landsat and Sentinel. And for this project, we'd have to remove all the Landsat channels except the blue, green, red, and near infrared. For this project, I actually got rid of the near infrared too, but you can include it. Now, the next normalization is the digital number to reflectance tool. As sensors do not provide the information, maybe in the same unit, some can be in reflectance, some can be in radiance. So we want to make sure that all the images we're working with have the same type of measurement. So we're going to use a reflectance to normalization for normalize. And although the reflectance is generally a value between 0 and 1, we're actually going to be scaling it to 10,000. So we're going to run the tool DN2 reflectance, so digital number to reflectance. And we can actually see the effect this has on the image histograms of the pixel values. So we can see here the raw image between the Sentinel and the Landsat. The Landsat has pixel values ranging from 0 to 50,000, while Sentinel is between 0 and 9,000. Now, if we were to enhance the images together, the system will create a table between 0 and 255 based upon the pixel values. The problem is that if they're not normalized, the histograms will then be compressed, especially the Sentinel, so we're actually going to get a significant difference between the images. But once we've run the tool, we're going to see that the histograms are quite different, or closer related, with the Landsat now transformed between 0 and 8,000. So now when we normalize, or now when we color balance, things will be far more easier. So here's just an example. These are the two images for Sentinel and Landsat. The Landsat is behind, and we could see that by enhancing both the images together, they're very different. One's very bright, the other is very dark. But once we perform the normalization, we could see that they're more similar and that our color balancing will actually work or be easier. Of course, if we're working with Landsat data imagery, which I used, we can generate high-resolution multispectral imagery with the panchromatic. And to ensure that we maintain the spectral fidelity, I ran a MRI fusion. Now, to begin the Mosaic tool, we can access it through three locations. We can access it through the Geomatica toolbar. It's the third button or third icon from the left. We can access it through Python and through our easy interface. When the user opens up the Mosaic window, they'll be greeted with this window here for Mosaic editing. We can then select the icon in the top left called New Project, which will start the Mosaic process, the wizard process. The first window brought up is the source imagery image. Here, the user will select and load their processed ortho-rectified imagery into the window or into the Mosaic tool, and it will display the image distribution and overlap. Here, we can then identify if there's any images we do not want to include. We can then select them and click Remove. The second step is the Mosaic definition, where we will create the Mosaic file, set the projection, and set the resolution. The projection and resolution will already be set, but we can always change it by looking at the data we're loading in. The Mosaic preparation window is the next step, where here the user can set the cut line methodology, the color balancing method. They can choose to use local or global masks, and I'll go into that in the next slide. We can set the blend width, which is a low pass filter that will apply a smoothing along the cut lines or seam line. The next is a simplified cut line, which will just smooth out the cut lines so they're not a bulky design following the pixels. And the auto scale function, which normalizes the assorted imagery by looking at the mean and standard deviations. And the last is constraint, which actually is generally used for aerial projects or satellite projects with significant overlap, which will the mosaic tool will actually draw Theseum polygons to only cover the native pixels for each image. Now, a bit about the cloud or the masking. We can either use cloud masks, which as clouds can skew the color balancing statistics, these masks will omit the digital numbers from the auto color balancing, and the system will be able to identify the cloud locations and then search for the overlapping images that contain no clouds. Additionally, we have the water masking, which is more of a global mask, which will omit the water from the color balancing operations. And as water location generally remains consistent between the images, we can create a single water mask layer. Once we've set the mosaic, we can then generate a preview and identify the quality of it. And if need be, we can then perform manual edits by opening the mosaic to a window. We can select 1, which will open the preview. 2 is finished, which will bring us to the mosaic window. Once we've select finished, then we can perform the actual edits. We can do cut line editing, so checking for artifacts, reshaping the cut lines or seam lines to fix blunders, then perform our color balancing. And as mentioned before, we can do the more global color balancing, so set the overall color for the mosaic, and then go scene to scene, so control for the entire image, adjusting the color, and then do the finer details edits with the dodging points and refine the local color and contrast to make sure we have a seamless connection. Once we're satisfied, and if we want to check it at any point of time, we can always regenerate the mosaic preview for us to review the results and identify any areas of issue and go back to them in the mosaic tool. Just a few things about the color balancing as well with the dodging points. Here's just a quick example. We have 2 images on the left and the top that are quite different in the color, but we can throw down a dodging point that will match the scenes. In addition, in the bottom image, we have a very bright area of the city, but we can actually reduce its contrast only within that region with the dodging points to make it easier, nicer to look. Just a few more slides about the dodging points. So the automatic dodging points, as mentioned before, they'll apply localized color balancing edits for the seamless transition. So here's just an example of 2 images that are not seamless. So we can identify it, select the dodging point dropdown, choose the type of dodging point we want to match to. So we could choose both sides, place the dodging point along the seam line, double click, and there we have the color balancing. Once we're satisfied with the edits we've made, we can then add all the scenes to the mosaic and then output it as a full resolution mosaic, either as a single image or multiple tiles. And once we have our final mosaic, for this process, I only created a single item, not tiles. We can then perform some post-processing. And we have a smart GeoFill tool, which has a number of different functions, such as copying and pasting and exposure correction. So it's interactive, and the system can actually quickly scan and find candidates to fill any artifacts or blunders, and then offers some color balancing and blending operations as well. Here's just a quick example. We have a airport in a city region, and it's quite bright, and we can fix the exposure, fix it with exposure correction, darkening only the region of interest. Another example is we have a overpass, which has an artifact in the final mosaic, but we can easily fix it with the Smart GeoFill tool. So before I begin the demonstration, I just have another poll, and I would like to find out what are your main challenges that you're encountering when you're trying to create mosaics. I'm just gonna launch it, and I'd love to know. And so we have a number of different options. Either it's adjusting for color balancing, identifying and overcoming cloud and shadow and haze issues, performing some exposure corrections to rectify the highly saturated pixels, so what we just saw with the airport, publishing the content, so how are you making the mosaic? Is it just a single mosaic, or do you need help with tiling? And then some automation as well. So I'd love to see the challenges. Okay, I'm gonna let this poll go on for a few more seconds. I'm seeing a lot more issues people are having with the adjusting the color balancing. Okay, perfect. So this demonstration, I'm going to do some of the color balancing in the Mosaic tool. Perfect. I'm going to close it in 5, 4, 3, 2, 1. Thank you all who have inputted and took part in the poll. And now I'm just going to quickly talk a little bit of success story from our company. We were able to help produce a Landsat 8 mosaic over our entire country of Canada. What we can see here, it's made up of multiple individual Landsat images covering many different types of terrain, Arctic tundra, Canadian Shield, the Rockies, and yet using the mosaic system, we were able to produce a nice color balanced mosaic. So the demonstration data, I'm going to be going over Vancouver Island, located in British Columbia in Canada. I'm using images from the Landsat 8 that have been pan sharpened, a Sentinel 2A and Sentinel 2B. And now I'm just going to quickly show. So here's our Geomatica toolbar. Before I go into the Mosaic tool, I just want to quickly showcase some of the data we're working with. So here is the raw imagery without being normalized and pre-processed. So we can see that there's some quite big differences. The Landsat is very bright, while the Sentinel is very dark. After pre-processing, we can see that they're more similar. So our color balancing will be easier. And now I can go and open up the Mosaic tool. Take a few seconds. Thank you. I will minimize both of these. And so here's the Mosaic tool. I'm going to create a new project. And so we have our first window, the source images. I'm going to go into my File Explorer, and here are the imagery that I want to work with today. I'm going to drag and drop them into the source file list. Here the footprints have been highlighted or displayed. If I don't want one, I can always just select remove. But for this purpose, I'm just gonna say, let's keep them off. So I'm gonna go to the next operation, the mosaic definition. I can set the output file here, or I can do it later. I can just go to browse, go to user, for instance, and just say mosaic Victoria or Vic. Save it. We have the projection, everything's fine. I could choose the output type, single file, I can do tiled, I can define it by polygons, but for this instance, I'm just gonna leave it at single. The next operation is the mosaic preparation stage. Here, I can choose the cut line methodology. I could choose if I want to make a use of a global mask or just local masks. If I have the cloud coverage or masking from our atmospheric correction tool, I can then select the local mask and choose the vector or a bitmap, or if I even have the data supplied to me. Again, with the color balancing, I can again do the global mask and the local mask. And once I'm ready, once I'm happy and satisfied, I can then select Generate Preview, which will generate the preview in the Mosaic window here. The problem is I'm not going to click Generate Preview and click Finish right now, just for the interest of time. I actually already have the stuff ready. So I'm going to showcase what would the result look like after you click Generate Preview and then click Finish. And so we can see that these are all the images. I can perform my cut line editing. So I can select the image here. We can scroll around, try and find areas of issue. I can identify that this area here are some clouds. And if I want to remove them, I have a number of different capabilities. So in the top toolbar, I'll just go into detail about a few of the tools. Again, Mosaic creating, opening, saving. If we are dealing with large projects, we can use a Mosaic overview to only select a certain subset. Zoom to overview. If I make a mistake, I can always undo them. Of course, simple zooming, panning tools. If I want to change how the image is displayed, I can do some enhancements. I can change the contrast, brightness, just to make everything darker or brighter, which will only have just visualization effects. It won't actually be affecting the pixel values. I can change the I can use RGB mapper to change the channels that are being displayed. If I want to only look at false color composite, if I had an IR, I can do that here. This is cut line editing. If I want to edit the seam lines or cut lines, this tool right here opens up the cut line editing tools. I can select different images. If I am dealing with a large project and I want to keep track of the images that I have already color balanced, I have a image status stamp. So if this image right here is good, I can click green for the image status of verified, but I haven't yet. Here's the cut line edits. I can select an image and reshape the cut line to what I require to fix any blunders. Here I can select the images individually, perform the enhancements I require, increase the contrast, decrease brightness as well. As displayed in the presentation as well, we have the dodging points accessible over here. We can drop down, use current adjustment. I'll go into a little bit of detail about the dodging points, but we have a lot of resources already available. If anyone has any other issues or questions, they can look at the other YouTube videos. But I'll use them for this presentation. And then, of course, if we have a dodging point, I can select one. Here I can increase or decrease the contrast and brightness of the images. Another good important point is the display all cut lines. If I want to visualize what the mosaic will look like without having these colorful cut lines visible, I can just display or select display and it's removed. Okay, so for now, one last thing, we have some settings. If I'm doing some editing and I could only affect the contrast or the brightness as well and different types of channels. This may be useful if you're dealing with different multi-sensors. Potentially, if you're making some edits, you may need to change it from both to brightness, for instance. We might see that later on. So I'm going to begin with some cut line editing. As I showed over here, we have some clouds that we could remove quite easily from this image by just changing the cut line. So I'm going to select the image, select the reshape tool. I can then edit the cut line to go along the water. Make sure. And then that's the extent of the image. So now we have all the clouds removed, although we still have some color balancing we need to work through over here. We can easily deal with that. But we've edited the cut line. I can even go around and change some more if need be. But there's clouds there, so let's just select the undo button and remove it. Okay, we can go across the entire data set as well, but to do some edits, but we're fine with this right now. The next step will actually be image color balancing, where we'll select the actual imagery and edit the contrast and brightness. So for this image, I can turn off the cut line so we can see it's just potentially a little darker. So we can maybe increase the brightness, a bit too different. So let's go back and maybe decrease the brightness. It's a little bit, it's quite nice default thanks to the automatic color balancing. But if we scroll around, for instance, this image does seem a little brighter than this one, so we can just decrease it as well. Just a nice brief decrease. Wonderful. So I'm going to then make use of the finer color balancing with the dodging points. And we're going to leverage this area. Now we have a lot of water here, but we can actually work around that. So I'm going to select the dodging points, and we have 4 different options. So the use current adjustment acts more like a blocker. So it will prevent any color balancing occurring around it. So we can set a blocker at this end and this end of the ground to make sure that the water is not going to have any effect on the color balancing. I can then either auto match to both sides, so it will both edit, or just a single side. Let's try both sides. I can drop down the dodging point. I'll get rid of it just to see. I will remove that. We can see that they've been edited. If I want to do some edits to the water as well, I can still leverage the current adjustment. Let me just visualize cut lines. We see here that there is a difference between the water. Again, I can use current adjustment, make sure that the land doesn't have any impact. But if I don't want any of the color balancing to affect this land, I can actually make use of our floating points, which can be placed up within the image, not just along the seam line, and set these as a blocker just to make sure that the land isn't actually affected. Okay, once that's set, I can then go back to the edge dodging point, select both sides, and we can see that it has been changed. I can go back to maybe single side, see the results. It's been edited. And I can also set a blend width to make it more seamless. Just another quick example, let's say over in this region, we have the island, very different between the two groups, between the two images. Throw the dodging points with current adjustment. Let's select single side. And the island has been color balanced. Now, as I mentioned before, we can also affect the brightness and contrast of the dodging points themselves. So let's do that for this city region. It's very bright. Let's reduce that. Let's fix that. So again, I'm going to use dodging points. I'm going to select a barrier, create a barrier around the area, just so my edits won't actually have an impact on the greater image itself. And then I'm going to select a few more. Okay, I'm going to hold select, hold shift just to make sure. Wonderful. I can then change the contrast here if I need be, just to fix it up. I can do some darkening as well, just to make it more visually appealing. Wonderful. If I'm satisfied, I can go and save the project, which will ask me to regenerate the preview, so I can then go back into focus, which I showed earlier, and do a bit additional QA. Again, we see that this area is quite dark, so what I can do is I'll select this image, throw along some dodging points to make sure that I'm actually not affecting the islands. Okay, and we can then throw in another dodging point. Okay. So these are the steps that we can take to perform the mosaic editing, as I explained. Once we're satisfied, as mentioned, we can go to the source images, and we could first define a mosaic. Previously, I didn't do that in this project, just to show. So here we have our definition, what kind of mosaic we want to make. I'm going to set an output. Let's call it mosaic RC1 or RC1_webinar. Here's the kind of mosaic we're going to produce. I can change the RGB mapper. So currently it's setting red as blue and blue as red. So let's change them. Close. I can do an enhancement just for visualization. Wonderful. Satisfied, I can click OK, and it will produce the mosaic. So it's created the mosaic, and now if I select the source image, I can add all these images into the mosaic. Now for the interest of time, I actually have already done that. So I'm going to select to minimize. and go back to our focus window. So here I can select Mosaic Preview. This is the kind of tool I was talking about. We can see some edits. We can maybe identify any areas of issue. I could go back here and fix it. Back to this area, maybe do a bit of color balancing in this area too. But once we're completed with our edits, we can then go back and do our final post-edit processing. This is what I was able to produce, nice and seamless, exactly the same image before. And I made sure to keep a few of these clouds so we can do a bit of post-mosaic editing with our Smart GeoFill tool. So I can zoom into the area of issue, and our Smart GeoFill tool is located under Tools in our focus window. I could select Smart GeoFill. Here, I can do a number of different things. I can highlight areas. Let's just say example here. I can reduce the contrast, change brightness. I can set a blend width. I could choose the type of width of pixels. I can actually automatically apply color balancing to it as well. Again, show the selection. I can remove that. I can paste candidates, as you saw with the highway overpass, and then save the image. So I'm going to reset the selection. So first thing I'm going to do is remove this cloud. Let's get rid of it if this is a problem. So I can open up, which will load our folder that we've produced the mosaic from, or all the images. I can select all of them. And because there's overlap in this region, if I make another area of interest, let's say over this cloud over here, I can then double click. We have the two options, the original image, the original Landsat, or I can select next, which will pass through all the other overlapping images, and the other one is the Sentinel. And here we have a nice cloud-free image. The problem is it's a little bright, but we have the automatically apply color balancing tool, and I can choose some blend width. So let's set a blend width of, let's say, 20 pixels to make it nice and seamless, and then automatically apply color balancing. And we can see it's quite nice compared to everything else. So selection edge, and now no one will know that there was a cloud there. If we like this, we can then paste it in. Let's just quickly load, save it to the mosaic. And now when we provide this to our customer or users, they will not know that there was a cloud over that region. So this is just one of the ways we can use the Smart GeoFill tool and other post-mosaic editing tools. So just a brief summary of the mosaic tool. So this new mosaic tool provides an easy to use method for manual and automatic workflows. The mosaic system offers cross-sensor resolution and projection compatibility. And then of course the new .mos file format offers new and independent mosaic capabilities. So I have one last poll for everyone. I promise it's the last. And I'd like to know, given what you have seen today, would you be interested in finding out more? So I'm going to launch it. So if you are interested and you'd like us to contact you, that would be amazing. We can discuss. If you want to do your own trial, you can download the trial version, and you can allocate some time. If you're not interested, that's fine too. We also have lots of other resources on our YouTube channels. All these webinars are posted. If you have more questions, we're always happy to answer them. So please feel free to message us. Wonderful. Thank you everyone who is adding into the poll. Wonderful. I'm just going to let it go for a few more seconds. 10 more seconds, that's all. Exciting. Okay, I'm going to go 3, 2, 1, and I'm going to close it. Thank you, everyone. And I'd like to do some QA, and please post your questions and we can hopefully answer them. I've had a team as well who have been answering questions as this webinar has processed. So hopefully those have been answered, but I can take a look. So I'm just going to take a quick second. Let's see. Okay, so let's see one other question. So one question is asking what modules are required, what I worked through, what I processed. So I used Geomatica Prime at core as well, and of course, depending upon what you're trying to replicate, the best thing actually it is to contact us and please explain your technical requirements so we could tailor a solution for your needs. Let's take a look. Another question is about working with images from different seasons. And for that, I'd say our bundle method does have capabilities, but of course, if you're working with different seasons, it will be different. That will cause problems, but we do have a number of tools and techniques that we can employ to help produce a nice and seamless mosaic. If there's any other questions, wonderful. One question was, can we process images without color balancing? And that is correct. We can. You could choose not to if you need. I'm just going to take a quick look. Thank you everyone for your patience as I look through the questions. So one question was, is this a module? This is the Mosaic tool, but we also have this capability in GXL, so we can process all your images and perform the color balancing with some Q&A steps using the GXL. Oh, the module that brightened the darker images, it was, I just used some enhancements, but for the normalization, I did digital number to reflectance. Okay, move on without color balancing. The same histogram that you actually saw in my presentation, someone asking, did I use the same histogram for this Vancouver data? That's actually from my data set, of course. So all the data I showed you, the histograms were all from the original data that I pre-processed. So that change I processed and I used. It was actually for Landsat image 50. It's wonderful if you have the tools, but you have never used it yet. It's great to hear that. We're here to help. We're here to make sure you're successful. So if you have any other questions and you need any other help, please let us know. We're always happy to assist. Okay. Let's see. So for imagery with different resolutions, how does it work? We do some resampling. So it can process and produce a a proper resolution image. We do have lots of post-processing and pre-processing tools. We're always happy to go into detail about all the different tools we have available. If you have any other questions, again, please let us know. Wonderful. So I'm going to have some questions for a few more minutes, and then thank you again, everyone, for attending this webinar. If you have any questions that we don't cover, please send us an email. We'll be happy to answer them. And if there's anything else you want us to showcase, please let us know. We're always happy to get some feedback.